Hello ladies and gentlemen. Today myself, Joseph Doumet, Hussein Haider and Rodolphe Jasser will be discussing our ergonomics project held at Silver Logistics LB. So first we will be discussing the company introduction, followed by the areas at which we conducted our studies, and then the environmental analysis, followed by the problems that we observed, as well as potential ergonomic solutions, and then a full analysis of adding a new machine, followed by the shift and worker efficiency, and finally a cost-benefit analysis presented to management. Okay, to begin with, the company is a newly established company in 2015. Its main and only focus is producing filters for the government-owned Cedar cigarettes. It is a modest company currently operating a single line with future plans of expansion. The first thing that grabbed our attention was these images found at the facility, which have to do with ergonomics and its principles. So this is the plant layout. This is the door over here. This is the machine, packing department, second floor warehouse, second floor mechanical engineer's office. We have a flow of material from the warehouse to the production line, to the packing department, and back to the warehouse. The different products produced at Silver Logistics, they differ in the size of the diameter, as you can clearly see here. There is also a difference found between the same types, which has to do with porosity, which is the amount of nicotine that can be absorbed by the filter. This is why we have Cedar's Blue and Cedar's Silver. The flow process, as you can see here, this is where the raw material starts, tow acetate. It is a tissue-like substance which is soaked vertically in a process called blooming, and then it is stretched in order to have its optimal shape. Then it is sprayed with triacetine in order to bond the fibers together, followed by tow feeding, and then rod formation, where all the raw materials join forces and form the circular shape of the filters, followed by cutting to specific sizes, delivery, then packing. The three areas of study consist of the offices, the warehouse, as well as the production floor. We decided to begin our project by performing an environmental analysis of the three areas of study. As you can see here, we calculated the recommended illuminations and found out that the illumination at both the factory floor and the warehouse fall below the limits, as well as the colors for both the ceiling and the floor are out of bound. Improvements can be seen by changing the color of the ceiling to white, as well as changing the color of the floor to dark gray, which would definitely eliminate the evident glare found at the factory floor. The second environmental analysis had to do with noise, which was calculated at the beginning, middle, and end of the production line. A noise dose level as well as a time-weighted average was calculated, both showing that improvements have to be done. They can be seen by providing earplugs or headphones to the operators, which would eliminate any damage. The third has to do with temperature. The humidity must remain 64% according to the manager, Mr. Fred Hatem, in order to preserve a longer and healthy life for the raw materials, especially triacetine. The temperature at the warehouse, as you can see, is below average. After comparing it to the thermal comfort zone, the operator works above this thermal comfort zone, and as we know, heaters must be installed in the warehouse. The final environmental analysis is ventilation. The number here for the warehouse falls much below the recommended air velocity. Improvements can be seen by adding ventilation fans to the warehouse in order to increase the airflow. Just a note on this subject, the second floor warehouse is completely isolated. It has no windows, no fans, and no ventilation system. This is why the ventilation is very low.
Okay, one of the main problems that we encountered in this company is the problem of seating. So team members studied a person's posture when sitting on his or her desk. So a workstation checklist was performed. The critical body dimensions were eye, elbow, and buttock, knee, length and height, and the population observed was the middle-aged woman. So we generated the anthropometric values. We can see it. The anthropometric values are eye height, elbow height, popliteal height, buttock knee length. Also, we had some complaints of workers of the bad design of their office, especially the table. So team members redesigned the table in the secretaries, and we got the three main critical dimensions. Also, team members generated and conducted a Pareto chart analysis to find the main root cause of downtime. This is our Pareto chart. We found out that the main causes are the road brake and stop on link-up machines, which constitute around 76% of the downtime problem. So a glue nozzle had a bad profile. After almost 1 hour, glue was building on the nozzle tip, which led to breakage. So team members considered a design of a new nozzle. Now, as for lifting, team members conducted a study of lifting at 2 area locations in the company. The first one was at the end of the production line when packing boxes, and the second location was at the upper floor warehouse where workers lift raw materials and store them. So we calculated the RWL of the process at the end of the production line. So we got the RWL, or lifting index, of 0.23, which is less than 1, so it is an acceptable lifting. However, due to the infrequent lifting at the upper floor level of packing the box container, we couldn't calculate the NIOSH lifting index here. However, due to some complaints of workers about the heavy boxes and containers while lifting, team members recommend the use of back belts and ergonomic crane.
The third problem observed at the company was